So in quantum mechanics, there's this thing called a bracket, and it was developed by Dirac. This is like Dirac notation. And in the bra part, this is the bra part, and this is where you place your observables of the quantum system. And this is the ket part, and this is where you place the states of the quantum system. Observables are things like energy levels and momentum and spin up, spin down, things that you can observe. They go in the bra part. And this symbol here is the measurement. So you can measure observables, and by measuring the observables, you can find out what state the system is in. And what goes into the bra part are called functionals. And what goes into the ket part is like a vector. So a psi can be a vector of states of the system. And this is a measurement of the observables. And that's like a function. So why is it that these are functionals and these are vectors? Why aren't both of these functionals or both of these vectors? Why are observables functionals and not just vectors or matrices or scalars? So we got this thing called the Stern-Galick experiment, where they take silver atoms and shoot them through a magnetic field and record their spin of the electron in the outer orbit, the valence electron. And with classical physics, you would expect them to measure the spin of the electron to be up or down or anywhere in between. It should give you this spectrum of measurements from up to down and then everything in between. But what they found was that when they measured it, they either got up or they got spin down, and that was it. That was kind of odd. It's like, it's quantum. It's either up or down. There's no in between. So then they thought, well, let's take this a step further. So they ran it through the Stern-Galick experiment, and then they blocked the spin downs and just let the spin ups pass through. So let's say this is in the x direction. So then they let all the spin ups in the x direction run through another Stern-Galick experiment. And they did this one in the y direction. And then they only got spin ups and they got spin downs in the y direction. So then they blocked the spin downs in the y direction. And then they ran this through another Stern-Galick experiment back through the x direction. And when they did it, they found out that they were getting spin up and spin down again. And that was very unusual because they've already blocked the spin down in the x direction back here on the first experiment. Now they're doing it again on the third experiment, and they're getting spin downs again. And with classical physics, you should only be getting spin ups. You shouldn't be getting any spin downs. So they're wondering what caused this to become spin down when we blocked it over here. Now they're showing back up. What could have caused that? So the only thing they can come up with is the very act of measuring. Measuring the system has an effect on the state of the quantum system. So measuring the quantum system affects the state that the quantum system is in. So measuring, for example, in this case, the observable was the spin. So by measuring the observable, they actually can affect the state of the quantum system just by measuring the observable. So that's why when you put things into the bra part of the bracket, it's a functional, because by the very act of measuring the observables on the bra part of the equation, it has an effect on the state part and the ket part. It has an effect on the state of the quantum system. That's why these are functionals over here. and these are not functionals over here. These are dependent upon your measurement. Whenever you make a measurement, it'll have an effect on what state you find the quantum system in. Functionals over here in the prop part.